This is a short lesson we have about line plots. Okay, so go ahead and get Notebook 8 opened. If you need to pause the video, do so and get to Lecture Notebook 18. And we're going to discuss one main example. And these line plots are great when we're looking at a time series plot. What's a time series plot? Well, it's something that happens over time. So the line plot will help me see trends over time. Okay, so first we have to do a bit of data cleaning, okay? And so we use the dot select to focus on just two columns of data, and we use dot relabeled. Now, dot relabeled is a low frequency use for us during the semester, but it can be really helpful, and you'll see the column titles become much better when we relabel them. And also I want to say that it talks about sex, but it has three options. And the zero sex option is adding both 1 and 2 together. Okay, so 1 is a total of people and not segregated by sex. And then what's an age, like 999? Again, this is a way to group everybody together that's alive on the earth at one time. Okay, so that's what we're looking at. That's going to be our example. So let's jump into the notebook and make sure you initialize. And here is the census table. And as if you read, I did say it's a bit of a mess. What do I mean by that? Well, these column titles are really dense and all caps and hard to read. And again, you're seeing sex equals 0 and some stuff going on. So yeah, the data set's a bit messy. And so the first part of our example is just going to be cleaning things up. Okay. So the first thing they do is they select only 4 columns, sex, age, and then the population estimate in 2010 and the population estimate in 2014. And then they immediately relabel column 2. Okay, so remember, the computer starts counting at 0. So the sex is column 0, the age column is column 1. So column 2 is 2010, column 3 is 2014, and you can see that they're relabeling column 2 as 2010, relabeling column 3 as 2014, and oh my goodness, now we have a table that looks a lot better. Okay, and then they're doing the sort by age. Why? Well, look at the 0 age category, right? There's 3 rows. And if you notice, the 0 row actually is the sum of the 2 below it. So again, sex 0 just means everybody. And 1 and 2 are the biological sexes, okay? So this has really helped clean up the data set a good bit. All right. And there is this other thing. And I also want to show you this. This is really cool. This is a quick way to do descending equals true. All right. So normally if we want to sort by age from top down instead of bottom up, right? What we would do is we would have a descending equals true. Boom. It turns out that I don't need the descending equals. There just aren't that many options with sort. And if I put in just comma true, it does that descending equals true without having to type the descending equals part. Okay. And again, we get this age 999. And like I said, I believe it's the sum of everything in the table, the columns all the way down. Okay, and I wish this would quit. I know the notebook has changed. Leave me alone. Okay, so we've done the simple sort with descending equals true. And now we finally get to the line plots. Okay, so look, they're going to do no 999s, and it means exactly what they say. They're going to remove everything that's below 999. excuse me, they're going to do a dot where, and they're only going to accept values that are below 999. So they're going to get rid of the 999s. And they're going to remove the male and female, right? So their no 99 is going to do where sex equals 0 is dropped. Right? Sorry. They're going to do where sex equals 0, and they're going to drop the sex. Okay? So they're only keeping the combined. And this gets us a graph of everyone. Okay? And see, we do everyone dot plot. So the table name is everyone. We do dot plot, age equals 2010. So this is the 2010 census data, and you can see exactly what you'd expect, right? Early on in the graph, right? You see things that, and it's going up a little bit. Why? Well, you know, people are being born, right? But there comes a point, and you can look at the graph, you know, it happens about the age of 50 to the mid 50s, early 50s. The graph starts going down. And why is that? Well, sadly, if you see down here, we're looking at age on the x-axis. So obviously, as people get older, it is less likely that they live and live and live. Okay. So we can add a comment, and it's still doing that, okay? We can add a comment that say, hey, this is the US population, all right, and show the graph. Or I can print out something to say what the graph is. And then, of course, they're showing us this plots.title that I'm allowed to throw in, which puts the US population here at the top of the graph. That, again, is a low frequency thing. This dot title is low frequency, but it's very useful when you have several graphs in the same workbook and you're trying to remember what the heck the thing was. Okay. Now then this is interesting because now we're looking at plot for age, but we have two numeric columns, the 2010 census data and the 2014 census data. And the thing to notice is that the gold line plot is just almost identical to the dark blue line plot. And it's for the reasons you'd suspect. Everybody who was counted in the dark blue just got 4 years older. Okay? And so that's why they look very similar. Now they're going to talk about males and females. So they're doing some work here to get male and females. So you can see the table we have with age, male and females. Now they're plotting based on age. And so because if I plot based on one column along the x-axis, every numeric column that it can plot, it'll put along, it'll put a plot for. So that's why it did males and females. It's doing the columns, right? Age is the X column that we specified in the plot. So it does males and females. Stop it. I wish it would stop. Okay. And now this is interesting, and sorry that I can't display the whole graph at once, but you notice that early on, the dark blue shows up more, and it's a little higher. Not much, but a little bit higher. And then you notice that somewhere in here, right, somewhere in this graph, in here somewhere, right, it crosses over. And then over to the right, the gold line for females is higher. So let's see if we can unpack this just a little bit. And notice that around these ages here, what are they? Okay, so say from 30 to 40, it looks like is where the crossing or the equalizing initially happens. Okay. So let's just be clear. There's a slightly higher percentage of male babies born than female babies if we talk about biological sex. But it turns out that females are longer lived, and I don't mean this disrespectfully, they're more durable, right? They last longer and stay healthier. Okay, so the reason there's a higher percentage of females is because, I mean, there are actually more males born, and it's just slight. It's not even 51-49. It's really just a slight percentage preference in favor of male children. But it turns out that females last longer, live longer, and recuperate from a lot of things better than their male counterparts do. So that's the thing we're seeing in this graph. Now they're going to yank this out as array data. Okay, so they can create percentages. Why? Dang it. I know that it has changed. I don't want to deal with that error message. So what are we doing? So now we've got males and females and the percent female column, which they're going to plot. We're going to plot age and percent female. And notice that females start off as just slightly less than 50% of the population. Okay, and then what happens? Well, what's happening is sadly that the males, biological males, are less durable, and unfortunately some of them pass away. And so the females begin to take on a higher and higher percentage of the living population. And notice here in the mid 80s, when the ages are mid 80s, the population that lives that long is 60% female. Okay, so again, I'm sorry that it's a morbid example, but it is true. And we can see the truth. This is percent female, and you can see that they limited the plot here on the y-axis just so we can kind of see it better. But you see exactly what's happening, that women tend to live longer. Okay. And then we're doing the same thing with males. So now we have a percent male column that we've created. And you can see, obviously, what you'd expect. If the percentage of females is going up, then the percentage of biological males that make up that age group in the population is going down. All right. And notice that this chart bottoms out around 20%. And maybe I can get rid of it that way. Okay. It just is a nice use of line plots to show that trend over time. Now this ideal gas law, pressure times volume equals the pressure, right? Wait, I'm sorry. Pressure times volume equals temperature, sorry. And R is the ideal gas constant. Is it all that important? No. And this is a nice line plot that shows the relationship. Okay. And then we plot 1 over P against 1 over the pressure compared to volume. And we get a nice linear trend. And then the Charles law data table, it turns out that when we graph that, we just get a really weird looking graph. And the scatter plot shows what's going on. There's 2 different things that are happening here. And so why did we say this? I'm just going to get down here. This is from the movie data. And here they've done a Pareto chart. This is the one I wanted to get to close out the video. Sometimes, you know, a line plot just is not helpful. Okay, when it's helpful, like in the biological sex comparison through the ages, it's really, really useful. That line plot really works. But sometimes the line plot turns out to just not be appropriated. It produces some gibberish for whatever reason, and it is not enlightening. Okay? Have a great day, everybody.